Good evening, everyone. So I am Jabakir. I work as a project coordinator at OPA. I would like to welcome you to this webinar under the title of Carbonates Acidizing Principle and Practices that we will. So I am Jabakir.
So I think my colleague Jad is having a small problem with the internet connection. I will take over for the introduction, then give my presentation. So welcome to this webinar, everyone, under the title Carbonates, Acidizing Principles and Practice. This title will be presented by Engineer Amr Hijazi. Just a slight introduction about Engineer Amr. He's a senior reservoir engineer at GPC in Egypt. He's experienced in many areas like the reservoir engineering, simulation, nodal analysis, PTA, and reservoir economics. He's also an experienced instructor for reservoir economics course, and he delivered one course with us before in OPA. He has a bachelor's degree in petroleum engineering from Suez Canal University and diploma in contracting administrating for project managers from AUC. So before we start with this interesting webinar, I will give a short presentation about our upcoming courses in plan, our June plan. So first of all, I'm Omar Hamid, business developer at OPA. So for June, first of all, we have the recorded courses. Right now we have 9 recorded courses. The prices you can see on the left are the original prices before the discount, because we have a big discount right now running. Each one of these courses is between 15 and 20 hours actually, and it contains exercises and assignments. Also, you will get support from instructors when you need it or you have any questions. There will be a certificate of completion after you submit all the assignments. And as I mentioned before, the petroleum economics course is by Engineer Amr Hijazi, who's giving the webinar today. So after the discount, which is the aid offer, which one that we extended since like 2 weeks ago. So we decided to extend this offer to let more people join it, because it's a big offer, 75% discount on the prices that I mentioned before. You can register for this course by simply scanning this code by your phone and registering, or by filling in the link that my colleague will send in the chat right now. So please send it, chat, if you're here. Okay, so you can scan the code, or you can contact OPA after the webinar and register in the recorded courses. Also, Engineer Karim sent the link in the chat, so you can fill it in if you're interested in the recorded courses in one of the 9 courses or more, so you can register through this link. Our second offer, or our second planned course or type of courses, is the hydraulic fracturing using Fraccade, which was supposed to start almost 10 days ago, but we decided to extend the time of the start till 5th of June due to the exams for the most of the people who registered already. So this is a nice opportunity for the people who see the offer for the first time, because you can register in this course and benefit from still the Ramadan offer, which is 40% discount, $149.99. This is a 2 weeks course and 1 week project, 35 to 40 hours of live training. In the course, there will be 3 hours per day for 10 days. And in the project days, there will be 1 to 2 hours per day for 5 days. There will be real case studies and full support from instructor to answer all your questions inside and outside the sessions. Also, you will get a certificate of completion of the course, which will strengthen your CV and show that you're a professional in the hydraulic fracturing using Fraccade. So what will you learn in this course? You will learn about stimulation, candidate selection, hydraulic fracture basic concepts, fracture modeling, basic geomechanics and log interpretation, fracture software, how to use Fraccade, fracture equipment, prop bent, hydraulic fracture fluids, diagnostic pumping and interpretation, fracture treating pressure interpretation, fracture job QA/QC, post-fracture production. So the calendar for this course, as you can see here, the green days are the course days, which will start on 5th of June. The orange ones are the break days. So after each 2 course days, there will be a break day to refresh and to revision what was taken in the days before, and also sometimes to solve some exercises. And the last week will be project days in the blue color. So in this week, you will be working on a project or solving a bunch of assignments that need to be submitted at the end of the course. So if you're interested, you can also scan this code using your phone, or you can fill in the link that will be sent in the chat right now. And also you can contact us after the webinar on our social media and to know more about this course and to register for it. And finally, how to be an ambassador on OPA. It's very simple. You need to take just 1 course with us to join the OPA ambassadors community. It can be either a live course or recorded course, any type of course with OPA. You will benefit from big discounts on all courses in the future. If you are an ambassador, you will also get group discounts for you and your friends when you are an ambassador. So join our happy ambassadors. We will be happy to have you with us. So last thing to talk about is our upcoming services. We have 2 services that we will announce in the upcoming weeks. I will not go into details about them, but stay updated on our social media to know more about these 2 interesting services. First one is called 4x4. It's a encapsulated short course with low price, which will benefit you and make you a professional or experienced in a certain topic. So stay tuned about it. Also, another one is CV writing or checking or helping. So we can help you in writing your CV or in making some corrections or recommendations. So we will announce also this course very soon on our social media. So stay updated. Then some rules for this webinar. Keep your microphone muted and camera closed, please, to keep the focus in the webinar. Put your questions in chat box and they will be answered at the end of the webinar. Use the full name as written in the registration form in order to be able to take the attendance for you. And note that certificates will be sent within 1 week from today, so no need to send us emails or messages in 2 or 3 days about the certificates, because don't worry, we are not forgetting you. You will send it in 1 week. So always check your email, check your junk box, your spam, and you'll find within 1 week. Thank you for listening to my presentation. And now I give the mic to Engineer Amr Hijazi. Engineer Amr, the stage is yours.
Excuse me, Omar. Can you hear me well now?
Yes, I can hear you, John.
Okay. So before Engineer Amr, I would like to introduce Engineer Amr to you. And sorry for this technical issue on my microphone. So Engineer Amr Hijazi is a senior reservoir engineer at GPC. He is experienced in many areas that are live reservoir engineering, simulation, nodal analysis, PTA, and reservoir economics. Engineer Amr has also experience as an instructor for reservoir economics courses. He had his bachelor's degree in petroleum engineering from Suez Canal University and diploma in contracting administrating for project management from AUC. And now Engineer Amr will conduct his technical session. So Engineer Amr, now Engineer Amr, the stage is yours.
So thanks, Jad and Omar, for this interesting introduction. I would like to welcome everybody and good evening for all of you. So what I'm going to do now is I will present some ideas and principle about carbonate acidizing. So do you see my screen now, Omar and Jad?
Yes, yes, it's clear.
Okay. So again, welcome everybody for this presentation. So our agenda today will be we'll talk about well stimulation objective. Then we will go to carbonate acidizing principle. Then we will talk about some typical workflow that we use in acidizing. Then we will talk about the challenge and the recommended data set. This is challenge. Then finally, we will talk about case study. So as a petroleum engineer, the first important equations for us is the well productivity equation, which is the flow rate is equal to permeability multiplied by net bay thickness multiplied by the drawdown, which is reservoir pressure minus bottom hole pressure, divided by the viscosity of the fluid, multiplied by the formation volume factor of the fluid, plus the skin factor. So as a petroleum engineer, we have here two factors to increase our production rate. The first thing is to decrease the skin factor, which is the scope of well stimulation. And the second factor is the bottom hole flowing pressure, which is the scope of artificial lift. So what is the well stimulation objective? We have two objectives from well stimulation. The first one is to restore formation flow capacity to make the rock able to make the oil to flow. This happened by removing formation damage in the wellbore vicinity. We have two techniques here, wellbore clean out, and then we have matrix treatment. This injection of treating fluid are usually done below the fracture pressure. We don't want to make a fact in this treatment. The second objective is to create new flow capacity in our reservoir. This by increasing the flow area connected to the reservoir by highly conductive channel. And this is done by hydraulic frac, which is drop frac or acid frac. Usually injection of the treating fluid done by pumping fluid above the formation fraction pressure. So what is the well stimulation impact on our production? As we know, every well subject to decline. So if we take a decision to make the stimulation at certain time, so we add some extra oil to our production, then we have again decline in oil production. So this area, we add some reserve to our reservoir by making some stimulation to the well. But to have this gain in production, we should select the candidate well and make the proper design and execution for the job. So what is the valuable techniques now in the market? We have first one, wellbore clean out, and this includes tubing clean out and perforation wash. This is if we have a damage in tubing and perf and the completion. So we want to remove this flow restriction, which will consist of organic deposition, which are asphaltene and paraffin and the scale. Typical volume we use in perforation wash, usually 20 gallon per foot, and this treatment usually is circulated in the well, not injected into the formation. Second technique available in the market is the matrix acidizing, and in matrix acidizing we dissolve rock component, drilling fluid, precipitate, clay, and any type of formation damage to improve the well formation connectivity. Usually the damage is occurred near wellbore at depths less than 1 meter from sand face. Usually typical volume for this matrix acidizing treatment from 50 to 200 gallon per foot. And this small volume treatment injected below fracture pressure. We have another matrix treatment. This includes solvent and surfactant, depend on the type of the formation damage. And the type of the formation damage here is due to emulsion, wettability change, and organic deposit, or due to scale. And usually the damage happen near wellbore area, less than 1 meter depth of damage. Last technique is acid fracturing. We create long, high conductive channel for low permeability tight reservoir. This deep into the formation can reach above 100 foot as a fracture length. Typical volume for this treatment from 1,000 to 3,000 gallon per foot, and usually this large volume treatment injected above the fracture pressure. So what is matrix acidizing? Matrix acidizing is accomplished by injecting an acid to dissolve and disperse the damaging materials that impair the well productivity. Usually this happens in sandstone, or to create new impaired flow channels called wormholes. This is in carbonate. So this is a sandstone acidizing. We have here the quartz grain. Then we have a clay filling in the pores and the clay lining in the pores. And usually we have some cementing material, usually carbonate, and some damage here. So we want to remove all the damage here and the clay to make the pore space larger than the damaged one. So we end up after the treatment with this pore configuration. Usually in acid, we inject the acid and dissolve the rock itself to bypass the damage and perform what is called wormhole channeling. Usually this treatment, as we said before, below the fracturing pressure of the formation. So because we deal with matrix, so we critical matrix definition. So what is the critical matrix? It is the near well pull area where most of the pressure drop happen in the reservoir. In this area, usually it is from 2 to 5 feet from sand face because of the logarithmic relationship between the pressure and the radius. So as this logarithmic increase, the pressure drop increase here. So as we close to the new wellbore area, so most of the pressure drop happen here. So suppose if we had a damage, so this damage induce more pressure drop due to friction of the fluid in this damage to bypass the damage and come into the wellbore. So this added additional pressure drop. This usually happen after the damage. So delta BD is the additional pressure drop due to the damage of the formation. How we can represent the damage? We have the skin factor formula. So skin factor is a dimensionless parameter account for additional pressure drop due to the damage at the nail wellbore, and we represent it by what is called the Hawkins formula. Skin is equal to the version formation permeability divided by the damaged zone permeability minus 1, then the depth of the damage RA divided by the wellbore radius RW. So if S is positive, this will indicate that our reservoir is damaged. If S is negative, this means that our reservoir is stimulated. If S is 0, this means that we have a neutral, no damage, no stimulation. And as the contrast K divided by Ks is high, usually we have skin high. So if the contrast between the damage zone permeability and the version permeability of the formation is high, the skin number is high. So how we diagnose our well for possible candidate for stimulation, we have 3 common evaluation tools. We have pressure transit analysis, which will give us a skin factor and the permeability of the formation. We have also production bubble map. From production bubble map, we can know underperforming well and we can diagnose them. We can also view well production history and see the events that corresponding to decrease in production and see what operation like well killing and workover. Because after this operation, usually we have some damage, so we should monitor our production history. Also, production logging can give us indication of undamaged zone. We can record the BLT, and we can see that the damaged zone provide no production. So as a general rule, avoiding damage is much easier than dealing with it. So if you are going to do a workover operation, so you must follow the standard guidelines for doing this operation to make the damage is less, because this is a general rule of our experience. Acid is usually not the magic solution because treatment will depend on the type of the damage. So you should know what is the damage type you have. So if you have damage as a emulsion, you should use mutual solvent or demulsifier. If you have damage like wettability change, you should use mutual solvent with block damage. Then in oil well, we use acid and use with it the solvent or surfactant. If we have a high temperature, we use acetic acid. In gas well, we use acid plus methanol. If we have a damage like a scale, this depends on the type of the scale. If you have carbonate, we can use acid. If we have sulfate scale, we use a chelating agent called EDITA. If we have iron scale, we use HCl plus reducing agent. If we have chloride, only water is enough to solve the chloride sodium, the chloride of sodium. If we have hydroxide like Mg or Ca, we can use HCl with them. If we have silica scale, we use mud acid. It's a mixture of HCl and HF. Again, if we have organic deposit, we can use aromatic solvent like xylene and toluene. If we have mixed organic or inorganic deposit, we can use solvent in acid dispersion. And if we have damage due to silt or clay, we can use also mud acid. So what is carbonate formation? A carbonate works by definition. It's contain more than 50% of carbonate mineral. The most common carbonate mineral are calcite or argillite and dolomite. We have two types of rock, limestone and dolomite. The limestone is greater than 50% in calcite. Dolomite is greater than 50% in dolomite, CaMgCO3 by 2. And usually these two types have small amount of Mg, Fe, barium, strontium, and silicate. This can be found in any type of carbonate rock. So we have a lot of types of carbonate. We have chalky limestone, we have mudstone limestone, we have fossil-ferrous limestone, oolitic limestone, shirty limestone, dolomite. All of these depend on the depositional environment that happened during this formation of carbonate, and later on depend on the diagenesis process that the carbonate is subject to. So usually we have unique features for carbonate. So if we look at this picture, we can see buggy limestone. We have here some bugs in the two picture, and we have carbonate, fractured carbonate, and also sometimes we have dolomitized limestone. So in general, carbonate rock that we deal with are heterogeneous laterally and vertically. So we need to characterize carbonate well. So matrix acidizing chemistry is understandable and simple in carbonate, but usually we need to do characterization for the carbonate to select the best treatment for our carbonate. So usually this is the carbonate reaction with limestone. This is the chemical formula for the reaction. Calcium carbonate react with HCl, producing calcium chloride as a salt, plus CO2 plus H2O. Dolomite react with HCl and give a product like calcium chloride, magnesium chloride, water H2O, and CO2. And the benefit, the advantage of this reaction that both CaCl2, calcium chloride, and the magnesium chloride are soluble in the spent acid, and there is no risk in reprecipitation of this product as sandstone secondary and tertiary reaction. So usually reaction in carbonate is simple. So how the reaction is happened in carbonate? So the overall acid-carbonate reaction governed by two processes. The first one is the mass transfer of acid molecules to the surface of the rock itself. Then the second process is the reaction rate at the surface. So usually the slowest process of these two controls the overall reaction rate, and usually in calcite it is mass transfer limited. But the reaction rate is high in calcite, but usually the slowest process controls the overall reaction rate. So in calcite, it's a mass transfer limited, but in dolomite, in HCl, is mass transfer limited at temperature above 200, and reaction rate limited at temperature below 120-50. So if you want to deal with dolomite at temperature below this number, you will notice that the reaction of dolomite with HCl will be slow and very low. So because we deal with carbonate, we should know what is the wormhole. So the reaction of acid in both carbonate usually result in formation of highly conductive flow path. This flow path, which in the picture here called the wormhole. wormhole are capable of bypassing any damage we have in a reservoir. So if we want to make a carbonate acidizing, so we want to make a job that is result in wormhole formation. So the hard condition to make this wormhole is usually depend on two things. The first one is the injection rate and acid diffusion. So if you are inject with a low injection rate, you will only make what is called phase dissolution. If you increase the injection rate a little bit, you can have what is called a conical channel. If you increase injection rate to optimum injection rate, you will have this branched wormhole. And if you increase it more than the optimum, you can end up with what is called the amplified wormhole. This connects the small pores of your reservoir, and it is not good because it will need much more volume of acid. So this is the core showing what is happening from low injection rate to high injection rate. As we see from low injection rate, we have only phase dissolution. If we increase the wormhole extended until we reach to the optimum one, it's a branched wormhole. Then if we increase it, you connect the small pores to your wormhole until you end up with amplified wormhole. So this can be done in a laboratory to determine your optimum injection rate. Usually we make what's called the core flood test, and from this core flood test we can know the injection rate that the pore volume to break through is the minimum. So usually this experiment we made it by increasing the injection rate and see how much volume of acid needed. So at low injection rate, we have here what is called the phase dissolution, and then we increase our injection rate. We have here a wormhole. Then we after this point we can see that here we have amplified wormholes and the pore volume to break through getting higher. So this is the optimum point to inject your acid. The second parameter that make our optimum wormhole is the acid diffusion rate. So as you decrease the acid diffusion rate, you get increase in wormhole length. Usually we reduce acid diffusion by what is called retarded acids. This includes gelling acid to make them high viscosity with polymer or surfactant. Then we have emulsified acid. We increase the viscosity by adding diesel to the acid. We have also retarded acid like alkyl sulfonate or alkyl amines. This retard are added to the acid to slow the reaction rate. And also we have a mixed acid between organic and the HCl. So the more retarded the system, the less acid is bent and the acid will be live. So we have deep penetration for live acid. So what is the typical acid workflow? Usually it begins with identifying your candidate. Then you make some economic evaluation for your stimulation job. Then we go to lab experiment the type of the damage and the location of the damage. Then we select our treatment fluid. This includes composition, additive volumes. Then we select our diversion depend on the petrophysical and geological interpretation of the logs. Then we apply. Then we go to the implement the job at the site. Then we evaluate the treatment success, and if we have any issue, we can modify the stimulation guidelines. So the first step is candidate selection. Usually we should have this minimum criteria to go to acid stimulation job. So for hydrocarbon saturation, for oil reservoir should be higher than 40%, and for gas reservoir should be higher than 50%. Water cut for oil reservoir should be less than 30%, and for gas reservoir should be less than 20 barrel per million standard cubic feet gas production. Permeability for the oil reservoir should be higher than 20 millidarcy, and for gas reservoir should be higher than 1 millidarcy. Reservoir pressure should be less than 70% depletion, and for gas reservoir it should be twice abundant pressure. And you should for sure have some extra capacity in your facilities to handle the increase in production. So this minimum criteria include the remaining reserve. So you should have remaining reserve. You should have well inflow productivity, and you should have facilities to handle the increase of the production. Then we go to the lab tests. The first one is to determine your formation mineralogy. This happened by co-analysis and the XRD and the selection. This is a graph show the XRD, and from this XRD you can know the percentage of each mineral in your rock. This is the same section. We can determine the second porosity from this same section. Then we do what is called acid solubility test. Acid solubility test to know the formation material, and we confirm it with XRD. And we use the same treatment fluid to make this solubility test. Then we have what is called formation fluid analysis. We make analysis for water, for formation water and oil. Usually we make this analysis for water to predict scale formation using software or calculation based on the cation and anion present in formation water. For oil, we make incompatibility test with our treatment fluid. We make API sludge tendency test. We have also make tests like asphaltene content and paraffin content because we can use xylene and aromatic solvent. We can also make a core flood test to determine, as we said before, the optimum injection rate. Also, we need to know the routability of the reservoir and the petrophysics like porosity and permeability. Usually, routability from contact angle. If contact angle is less than 90, we have a water wet reservoir. If we have a contact angle greater than 90, so we have oil wet reservoir. Also, from the core analysis, we have effective porosity and total porosity, and from core analysis also we can have permeability. So based on so the first thing in our treatment fluid, our acid type. We have many types of acid. The first one is mineral HCl. This able to dissolve carbonate. It has concentration up to 28% by weight. But the disadvantage of HCl is that it's highly corrosive and cause oil sludge. Another type of acids is organic acid. We have acetic acid and formic acid. They are weaker acid comparable to HCl, but they are used for high temperature wells greater than 250 Fahrenheit. They are non-corrosive and compatible with oil and not cause oil sludge. Finally, we have what's called retarded acid to reduce the diffusion rate of the acid. We have gelled acid by cross-linker or surfactant. We have emulsified acid also used for high temperature wells. We have chemically retarded acid, and we have also mixed acid. So this is a diagram show the difference between using acid HCl as a plain acid and the emulsified acid. And as we see, the wormhole length increased with using emulsified acid because it reduces the diffusion rate and make the acid life for deeper penetration. And this is the different dissolving power for different acid system used in carbonate acidizing. And as we see, the most powerful dissolving power for 28% HCl, and the less one for 10% acetic. It dissolves only 390 pounds of calcium carbonate for 1,000 gallons of acid. Also, we have a lot of additive in our stimulation job. This includes inhibitor, surfactant, foaming agent, neutral solvent, ion control agent, friction reducer agent, clay control, anti-sludge agent, diverters. So each one of these in catalog, or you can ask them direct. You should know why you use inhibitor. So if you use HCl, you should use inhibitor to reduce the corrosion rate. So for each one, you have to know the functionality of this additive. So the general function is to prevent excessive corrosion, prevent sludging, prevent emulsion, prevent ion precipitation, improve the coverage of acid of all zones treated, improve cleanup, stabilize clays, prevent reaction product precipitation, and disperse paraffin and asphaltene if you have it in your oil. So general rule to use the additive wisely and for a reason, not to add any additive without reason because it is costly materials. Then we go to determine the volume of the job and the injection rate. We have here guidelines to select our volume. Usually, if you have a temperature less than 15 Fahrenheit, if you have permeability less than 20 milliliters, you can use 100 gallon per foot for the acid. If for higher permeability, we use a higher volume of acid, and for higher temperature, we use less volume of acid. Again, we use, because we deal with matrix, so we inject below the fracture pressure gradient. So we need to terminate that the design. We put here, as we see, the fracture pressure gradient, so to constrain our injection rate. So this is the injectivity equation, but we constrain it with the fracture pressure. So the fourth part in our presentation is the challenge. So what is the challenge that we need in acid? First one is that choosing the right candidate to perform acid job. Second one is to design the optimum treatment, and this should have experimental lab test to know what is type of the damage. Third one is to choose the optimum diverter to get to treat all the zones for acid with acid. Fourth one is knowing the current fracture gradient. Usually we don't have the current fracture gradient because this information usually obtained if we have a dipole sonic data. So if you don't have dipole sonic data, you can do some guess for this parameter fracture gradient. Fifth challenge is we don't know exactly where acid is entered. So knowing the intake during the pumping. Last thing is quality control and quality assurance during the job execution. So this is the recommended data sets of, so if you are in a green field, which means that you are in a new field. So usually these open hole logs should be obtained like imaging log to know, to identify zone with natural fracture. We can use the petrophysical analysis to know the effective porosity and the initial saturation, water saturation. And also we should know the effective porosity from NMR logs. So we combine all of these logs to know, to characterize our carbonate. If we are in brown field, that means that we are in a producing field, and we expected some depletion in the new drilled wells. So usually we have this recommended also open hole logs, usually imaging log and NMR, but we recommend dielectric logs to estimate the water saturation exactly of the depleted layer. So if we see here the water saturation is all over the body, carbonate body, and if we treat this, we should expect that we produce water. Also, we can obtain cased hole logs like pulsed neutron tools, which give us saturation and water saturation, because we want to know how much water to deal with it in matrix acidizing. Also, from BLT logging, we can know which zone are oil producing and which zone are water producing. So diverters, we have two types of diverters usually used in matrix acidizing. We have mechanical diverters like cold sealer, cold tube. We use cold tube as a mechanical diverter. We have inflatable backer. We have a slotted liner with external casing backer. So all of these can provide a means of diverting during the job. We have also chemical diverter like particulate or salt and resin and benzoic acid flakes. This all considered as particulate. We have also in situ gelled acid like self-diverting agent SDA. We have also viscoelastic diverting agent VDA. we have modified polymer, and also we have foamed treatment. So suppose if we have 3 layers, each layer has a different permeability and skin. So we expect a different intake from our fluid. So we want all of these layers taking fluid. So we inject a diverter to make sure that we cover all of these layers. So typical treatment, what is called the pre-flush stage, and this may include any salt like NH4Cl or KCl. The function of the pre-flush stage to displace the formation fluids away and to convert the rock to water wet. So if so, the wettability here playing a major role in selecting fluid in the pre-flush state. So if you have a water oil wet rock, you should also in the pre-flush stage displace the oil by means of xylene or toluene to make your rock clean. Then we have main acid stage, and what is the main factor in selecting the acid is the depth of the damage and the temperature of the reservoir. So the main function of the main acid stage is to remove the damage and to create high conductive flow paths, usually called wormholes. And the third function is to keep reaction product in solution. Then we have post-flush stage. In this stage, we should also keep the water wet to make the flow back easy. Then in this also post-flush stage, we can use some additive that break the diverter if we use it between the stages. Then we usually lift the well with nitrogen and flow back the well. Also, this is a chemical diverter stage is optional, depend on the length of the perforated interval. Usually, we use it as between the stages, and we want to ensure better zonal coverage. So, if you have perforation less than 20 feet, usually we put a diverter stage. So we have 2 stages of acid, and if we have a perforated interval 40 foot. Usually we make it at 2 diverter stage, which mean 3 acid stage and so on. So this is guidelines for the interval length and how many number you need in your diverter. So what is new in matrix acidizing? We have 3 different areas in development in research and development. We have what is called the fiber optic enabled coil tube. This is coil tube with fiber optic. This allow recording distributed temperature survey during the treatment, which give us some information about soon what's the difference between didn't take acid, and we can modify the treatment and make it again. We have also research and development in diverter. So we have new diverter. We have re-engineered fiber-laden diverter, which is cross-linked polymer. We have also silica nanoparticles, which is developed in 2020. We have also some mechanical aids technology like fishbone technology. Usually this is done by placing liner and with some slotted drilling into carbonate rock. Then we make acidizing through this slotted. So this is called a fishbone. So the last thing in our presentation is to talk about case study. So the problem here, the well was drilled and completed in carbonate formation. When we perforated under balance, no flow occur on surface. Then we try to assess the well with nitrogen lifting, but also no flow on surface. So viewing the data, this is well was in green field. So usually we have image log, and the petrophysical analysis was sufficient to characterize our carbonate. So from image log, we can see that we have a natural fracture, and by count they have 97 natural fracture in this interval, which we make our perforation. From the petrophysical analysis, we get SCW equal to 20%, we have fire effective porosity is around 25%. We have an pay of 60 meter. We have permeability from 30 to 40 millidarcy. So based on this integration of the data, we decided to perform acid to remove the drilling damage and the cement damage. So we go to lab tests and we make XRD and solubility test. And from XRD, we know the percentage of calcite that we have in our reservoir. We have two zones. The first one has calcite around 31%, and the second one has calcite around 51%. And we, after we make solubility test, we found the solubility for the first one is around 44. And because the second one has a higher calcite percentage, we expect that we have also higher solubility. So solubility for the second zone was 55. So after lab test, we go to the design. So based on our on our porosity and depth of damage, usually the carbonate acidizing volume from 50 to 200. And from this graph, we can know how much we need based on our interpretation for the porosity. So from this graph, we find that the 100 gallon per foot for the acid volume. Again, as we said, we have natural fracture, so we expected that the injectivity will be low due to this natural fracture. So we use a diverter at the beginning. Then we make two stages of acid. This acid stage, then diverter, then acid stage. To determine injection rate, we need to know our fracture gradient. So due to we don't have any sonic data to determine the fracture gradient, so we used our original experience. That field was a normal faulting regime. So we use the minimum fracture gradient for normal faulting as 0.65 psi per foot, and this will lead us to determine our injection rate. So our injection rate to keep the injection below the fracture pressure was 1.5 barrel per minute. Due to the length of the perforated interval, also we go to the mechanical diverter option to assist the chemical diverter option. We use the cold tube. So this cold tube enhance the zonal coverage of the acid. And again, because we have a longer interval, we decided to use a cold tube. So we monitoring our job by plotting the inverse of injectivity with time. And as we see from this graph, as the injectivity was low, this means that the inverse will be high. And as the acid dissolutes the rock and the injectivity is enhanced by the time. And after placing the second diverter stage, we see increase in injectivity, which means that the diverter habit take place and efficient to divert to the second zone. And the second zone, we have, as we see, the injectivity again is getting better with time until we reach scan -2. Then we make a post-treatment evaluation. We put the well on test. We make a flow after flow test, then build up. And the well was natural flowing with 500 barrel per oil per day. And from the build-up test, we can scan reach around -half. So this means that the job was successful and matching again with the scan evaluation during the job. So thank you and my presentation and waiting your question.
Thank you, Engineer Amr, for this interesting presentation. So if you have any question, please drop it in the chat. I will read some questions for you, Engineer Amr, and maybe you can answer them, okay?
You can ask me the question.
Okay, so the first question is, for acid fracturing, it's very important to have big perforations, or is it not that important?
For acid fracturing?
Yes.
Yeah, for acid fracturing, usually we need a big hole perforation to reduce the friction and reduce the new wellbore tortuosity. So usually we recommend perforating using big hole guns.
Okay, thank you. So other question is what kind of logging tools assist you in the acid design?
Usually logging tool don't assist me in logging design, it assists me in characterization of my work. So as we said before in this slide, so if you are in a green field, in a green field, which means that you are in or area where you didn't reproduce so much. So you should have these logs like image log to know the natural fracture where it exists. You should have a physical analysis to know the saturation profile, and you should have NMR to characterize your porosity. If you have a brown field, that means that if you want to you drill the well in a brown field, so you should have open hole logs like NMR and image, plus what is called dielectric logs. Dielectric logs provide us with two measurement, which are used in its equation M and N, cementation factor and saturation exponent. By the dielectric log, so we know exactly the water saturation profile and oil saturation. And if you don't have open hole logs, we can make it case. We use pulse Newton tools to know the saturation of the water behind the casing, and simply we can use the BLT to know which zone produce water and which zone produce oil. So this is the data set we need to characterize our reservoir.
Okay, we have a question that is what is the difference between open hole and cased hole acidizing?
Both of them principle are the same. We don't have difference between open hole and cased hole. We have this slide show the open hole logs and the cased hole logs.
Okay. We have a question. Do we have to acidize all wells after formation, or it's only for specific wells in situations?
Again, can you repeat your question, Jack?
Okay. Do we have to do acidizing for all wells, or it depends for specific wells?
Yeah, we make acidizing for the candidate well, wells that suffer from damage. And we know that if we make BLT or if we make a build-up test, we know the skin factor from build-up test. So if it is positive, so this is the candidate of our well. But first of all, you should eliminate any mechanical problem that may happen. So if you have a casing leak or tubing leak, you should know that all the system is okay, casing and the tubing and the perforation. So the only question will be about the skin. So if it is positive, we do as a job.
Okay, so we have another question. How many days or hours it takes for acidizing operation?
Usually depend on the interval that we treat. Maybe take 1 hour or 2 hours. Depend on the interval length. In horizontal well, it may take 1 day or 2 days.
Okay, thank you. Also, we have a question. The drawdown pressure in the formation should decrease when the permeability increases.
As the permeability increases, yeah, the drawdown pressure is decreases.
Okay. What is the diagnostic tools to identify the candidate well for acidizing?
So I will back to the first slide. So we have 4 methods to know the candidate well or to diagnose our wells. We have pressure transit analysis. We have production bubble map. We have production logging, and the final we have to review our production history and corresponding event.
Okay, thank you. Also, which type of acid is preferred for tight carbonate formation?
So for tight reservoir formation, we usually use acid frac, not matrix acidizing, and usually we use emulsified acid as a fluid for acidizing.
Okay. Thank you. So if please anyone still have any question, if you can please drop it in the chat. I will share with you the feedback form. So please, everyone, make sure to fill this form so we can always fulfill your needs and enhance and be better. So if anyone please still have any question, make sure to drop it in the chat so Engineer Amr can answer it. Okay, it seems that we have no more questions. So I want to thank you, Engineer Amr, again for this interesting presentation. It seems that all the attendees are really glad in this presentation, as we can see in the chat. So thank you everyone for being with us today. And also again, please don't forget to fill the feedback form. Thank you, Engineer Amr, again, and we will see you in the next webinar, hopefully.
Okay, see you guys in the next webinar, and I hope you are interested about this webinar. So see you, and please stay safe. Goodbye.
Goodbye.